Agile Data Engine, Tutorial, Speed up Event Data Processing. Agile Data Engine has several useful built-in features, and in this demo we will explore two of those features. In the context of event data, it is especially important to reduce the number of rows used in query processing. That's because there is usually a huge amount of data and the amount increases at every turn. The features used in this demo can be used to reduce both the number of rows used from a source table and the number of rows used from a target table. First, we go through both logics with the slides, and after that we go through the same thing in Designer. The first feature is Run ID logic. It simplifies and manages data processing by using sequential integer values called run IDs. These run IDs indicate the arrival order of data files. For instance, imagine you have several source files, with some of them already loaded into the data warehouse. With Run ID logic, the system avoids reloading the already loaded files and focuses on loading the remaining files in their original order of arrival. Further, Run ID logic can be enabled in loads throughout the data warehouse layers to form a chain of incremental loads, such as from staging to the data warehouse and onward to publish. With Run ID logic, only the unloadable data is loaded and in the original order of arrival. Let's look at an example. Event data is processed in batches. When a Run ID logic is used, we need to populate the staging table's Run ID attribute, which is often called as batch ID or STG batch ID. If the source file name contains a timestamp, it is most often the best value for the Run ID. Every time a new source file is loaded, a batch ID column is populated with the corresponding value. The Run ID values are also stored in the ADE's metadata database. That way ADE keeps track of what data has already been loaded and what hasn't. After the staging layer, the Run ID column is most often called Run ID or DV Run ID. Also, after the staging, Agile Data Engine populates the Run ID values for us. It stores the Run ID information of the tables and source target pairs, and loads only those batches that are not loaded yet. As we saw in the previous slides, Run ID logic reduces the number of rows from the source table involved in the processing. However, during data loading into the target table, the entire table must be scanned to avoid introducing duplicates. This is a common challenge in data processing and can lead to performance issues. Timeslot logic addresses this challenge by narrowing down the scope of data that needs to be scanned. Instead of scanning the entire dataset, only the rows falling within the designated time frame are considered. Timeslot logic's concept is elegantly simple yet remarkably effective. By focusing on specific time frames, it minimizes the processing load required for data insertion and manipulation. This optimization becomes particularly valuable as new data is continuously added over time, preventing the processing slowdown often associated with growing datasets. Let's continue the example. In this context, Run ID logic alone is not enough. When data is loaded to the target table, the whole table needs to be scanned so that duplicates are not added. This scanning slows down the processing, and it gets slower and slower as new data is added. The event data batches contain data from some time frame. Timeslot logic uses this time frame to reduce the number of rows that need to be scanned. The min and max values of the batch's timestamp are queried and used in the query processing. In the most optimal case, like in this case, the target table scan is not needed at all. Now we will move to Designer, where we go through the same thing again. Now we are on Designer. The entities are created beforehand, but they need to be modified to start using Run ID and Timeslot logic. For the source entity we don't need to do anything, but for the staging entity we need to tell which attribute is used as a Run ID attribute. The attribute is this, STG batch ID. And all we need to do is to add Run ID as a technical type for this attribute. After we have committed and deployed this change, ADE starts automatically tracking the values added to this attribute and values loaded via outgoing loads. Next, we will open a data warehouse layer entity that uses this staging entity as a source. Here we have a transaction link where we want to use both run ID and timeslot logic. First, we will modify two attributes. Let's select dv run ID as a run ID attribute and message timestamp as a timeslot attribute. When we have done that, we can go to modify the load. The load has already an entity and attributes mapped. We can check what the generated load looks like now. It is a very basic insert into statement that loads the data from the staging entity without any limitations. The outermost query contains a where condition that prevents duplicates from being added. But this where condition scans all the data in the target entity. Now we will apply the run ID logic. We have already told ADE which attributes to use as the run ID attribute. And now we will tell ADE that we want to use the run ID logic in this load. That is done by adding the use run IDs load option. After selecting the load option, let's check the generated query again. The statement looks almost the same, but this time ADE has added a where condition that limits the loaded data to the latest batches. Finally, let's apply the timeslot logic. That is done by adding the use timeslot logic load option. Let's open the statement one more time. Now ADE has included a statement that queries the min and max values from the staging entity's timeslot attribute. The run ID logic is applied to that statement also. And included the min and max values to the outermost queries where conditions.